Let's look at the solving exponential equations parts of our exponent logs packet. Solve each equation. So, for solving equations, for exponential equations, you want to do this. Let's refer back to the exponents manual from the rubric page on the Canvas. Page 21, solving exponential equations. So to solve an exponent, the exponential equation, you want to log b both sides. So basically you want to log with whatever the base is, and you do that to each side. And then that would give you x equals y. The log b's, they would cancel. And so you're just left with the exponents. Here's an example. 4 to 5x minus 12 equals 4 to 2x minus 3. You would log 4 each side to get rid of the log 4s. Then you just have the linear equation 5x minus 12 equals 2x minus 3. Solve for x. So for these kinds of equations, they might have a linear equation that simplifies to, or quadratic equation. So be careful with that and review your factoring rules and solving rules. Okay, let's look at example 28. 3 to the negative 3b equals 243. So we're going to log 3 each side. Now log 3 of 243, we could put that in the calculator. So on your TI Inspire, you could just go to calculate and then control 10 to the x, which will give you log, and then type in your numbers. Log 3 of 243. Enter. So we get 5 here. So that basically means that 3 to the 5th power is 243. And that's the way you can check this. So let's go ahead and write our next step. So those cancel. We have negative 3b equals 5. Now, log of something won't always be a pretty number like this. There are many instances where it's irrational, which is like in the next section. From there, you would write your exact answers first. So you would just leave like log 3 of 243, and then you would round it at the end. Now to solve for b from here, you'll just divide negative 3 each side, and then b equals negative 5/3. And then that would be your solution. Let's look at the next one. 29. 13 to the nth power equals 95. To get rid of that 13, we're going to log 13 each side. So those log 13s cancel out. So we have n equals log 13 of 95, which is approximately, we'll put that in the calculator. We can also do these on Desmos. Let's do this example on there. So we'll go to desmos.com/calculator, and then we'll type it in. Log _ 13. Press the right arrow key, and then parentheses 95. And then here's your approximate answer. 1.775. It says 10,000th. So I'll do one more decimal place. We have tenths, hundredths, thousandths, and then 10,000ths. So that's 4 decimals. So this would be your answers. So for these, I want you to write both the exact answer and the approximate. And then, of course, the steps needed to get to the answer. There's another way that we could do this that doesn't involve basing it or log base it by the number that you're given. You could do a base of e or a base of 10, get the same thing. Let's do number 32 with that. So we're going to subtract 10 first. So we have 13 to the 2nth power equals 7. We're going to ln each side. ln is just a log with a base of e. So from there, we'll move the exponent to the front. So 2n ln of 13 equals ln of 7. Divide each side by 2 ln 13. And then we have n equals ln of 7 over 2 ln of 13. And then we would put that in the calculator and approximate it. So we could go to our calculator, control divide, put ln of 7 over 2 ln of 13. And you have 0.3793. And this would be your answer. Now, if you solved number 29 using ln's instead, this is what you would get for your exact answer. You would get ln of 95 over ln of 13. If we plug that into the calculator, we would get the same thing as before. So a lot of times they prefer you to use ln's for one. ln has one less letter than a log. Also, a lot of calculators don't let you put specific bases in, and they'll only let you have either 10 or e. So it's good to know both methods. Let's do one more in this section, number 34. We have 2.4 e to the 4n plus 5 power minus 4 equals 44. The first thing you want to do is isolate the exponential part. So we're going to add 4 to each side. So we have 2.4 e to the 4n plus 5 power equals 48. Divide each side by 2.4. And then you have e to the 4n plus 5 equals 20. Now from there, we want to ln each side. And we would ln no matter what here because e is the base of ln. So those cancel out. So there you're left with 4n plus 5 equals ln of 20. From there, we're going to subtract 5 from each side. So 4n equals ln of 20 minus 5. Divide each side by 4. So n equals ln of 20 minus 5 all over 4. And then if we approximate that in the calculator, we'll go Desmos ln of 20 minus 5 over 4. and that's negative 0.5011. And that would be your approximate answer. Okay, try some more of these problems in this section on your own. Show the appropriate steps for each. Remember to isolate the exponential part first, and then log both sides or ln both sides. And then solve for your variable. You'll put that answer in the calculator and round it 4 decimal places. Remember, you could check the back of the packet for the key to see if you got the right solution. I believe the key in the back only has the approximate answer and not the exact one.